I've made this Node application that I have running on my local machine. It's running on localhost port 3000. It's connected to a Postgres database that I also have running on my local machine. And I need to take this entire web application and host it on the internet. So I'm going to do this by running it on an EC2 instance on AWS. So I'm going to head over to the AWS console and I'm going to select EC2 and I'm going to select launch instance. This is going to let me set up a virtual machine that runs in the cloud, where essentially I'll have to install the Node runtime, I'll install the Postgres database, and everything else that I need I'll install on this virtual machine, and then I'll be able to access it over the internet from anywhere. So I'm going to start by giving this a name. I'll call this my web app. And then next I need to select the base image. So this is going to include the operating system that the application is going to run on. And the easiest one to get started with is probably Ubuntu because it's the most common. We're just going to leave this as the most recent version. 64-bit x86 is great here. Then we can select the instance type and it defaults to T2 micro. And this is great because if you're still in the free tier of AWS, still in that first year, you won't have to pay if you have one of these running. After the free tier ends, you'll end up having to pay 1.38 cents per hour to run this, which is not too bad. You can get this cheaper by purchasing reserved instances, but we're just going to leave this as the default setting for now. Then we're going to come to key pair login. And we're going to access this virtual machine over the internet using SSH from our local machine. So we need to set up a key so that we can actually connect to the thing over the internet. And we're going to create a new key pair right now. So I'm going to name this, well, it's specific to the region. I'm running this in California and I'm running this from my MacBook Pro. So I'll just call this California Sam MacBook Pro, and then I'll create this key pair. And then immediately it will want to download this key pair. So I will download that into my downloads folder and I'll deal with that in a moment. Then we go to network settings where we basically set up the firewall for this virtual machine where we're going to allow traffic to come from. So I want to be able to log into the instance. That's this SSH stuff right here. And I only want to be able to log in from my laptop. So I am just going to select my IP address here. But if you wanted to be able to log into the instance, install software, modify code, things like that from anywhere, you could leave this as 0.0.0.0, but I'm going to select my IP address just to make it a little bit more secure. And then we are going to allow HTTPS and HTTP traffic from anywhere. Since this is running a web app, we want people to be able to access this thing. That's good for the security group, but I am going to click edit here to give this a better name. So I'm going to call this my web app security group, and I'll probably just use that for the description too, just so it's not launch wizard. I can scroll down and I could create more rules here if I wanted to create different TCP rules, but we're going to leave this alone right now. That's good. The default storage is fine. We can leave that alone. With those settings, we can click launch instance and this is going to set up that virtual machine for us. Then the very next thing we want to do is actually connect to that instance. I want to log in from my laptop so that I can start installing software and configuring this virtual machine. So I'm going to click connect to instance to get instructions here. And I'm going to go to SSH client and it gives me instructions on how to connect over SSH. So if I'm on a Mac or a Linux machine, this is just going to work. If you're on a Windows machine, you're probably better off using WSL, or at the very least use git bash, and things should just work for you there. So I'm going to copy this command to connect to the instance. And in order to log into that instance, I need to use that key that I downloaded, which is currently in my downloads folder. So I can just run this command from my downloads folder since it's looking for that key here. But the first thing I'm going to do is actually move that key, so California, into my .ssh folder that I have set up in my home directory here. That's where I put all my SSH keys. It's a pretty standard place to put those. So I suggest putting it into that folder. I can run that command from my SSH folder, or I can just run this from anywhere really, as long as I specify the full path. So .ssh / that key. So we're going to use SSH to log into the remote instance. That's this instance right here. This is their IP address for the instance that was set up, and the default user for the Ubuntu instance is going to be Ubuntu. So log in using that username, using this key, and hopefully this all works. So it's just saying, are you sure you want to connect? Yes, I am. and it didn't work right because I missed a step here. We're actually supposed to change the permissions of that key. Just copy and paste that in, and then this should work. So let's see, I'm just going to copy that SSH thing again. And this time, there we go, it connected. So you can see my terminal changed. I'm actually on Ubuntu, and this is the private IP address of that Ubuntu instance. So anything I run in here, if I run echo hello, this is actually running on the instance that is in California. This isn't running on my laptop anymore. If I open a new tab on terminal, this is my laptop, this is running in my home. Anything I run here is actually running on that virtual machine. One of the first things that you want to do when you set up a virtual machine, and I have some snippets on another page here, one of the first things you want to do is actually just update and upgrade the packages on the machine to make sure you're using the most recent versions of things. And this includes any security patches that might have recently come out. And when it asks you to continue, just hit enter. And this might take a couple of minutes, but once it's done, you can start configuring everything else on the EC2 instance. And one of the last steps here is asking which applications should restart. And I'm just going to select all of them. So I'm just using the space bar to make sure they're all selected here, and then I'll select OK just by hitting enter. It will restart those things and they'll all be using the most up-to-date versions of all the packages on the system. So that was a quick update of everything running on Ubuntu. Now I want to start running my application code. That's one of the first things I really want to do. So I'm going to install Node right now because that's how I run a Node application. I have to install Node and then use that to run the JavaScript code. But if you're running a different type of application, you would just install whatever you need for that runtime. So now I can sudo apt install Node.js. And now I should have Node version 20. Yep, that's there. And I could test this out. I could open up a Node REPL. I could console log hey, and that should all work fine. Like I said, this is a complete Linux machine, so you can install whatever you need to for your application. So for example, if you wanted to deploy a bun app instead, you could just install that instead of Node. Let's see, it needs unzip. So I'd have to install maybe a dependency, sudo apt install unzip, and then I could rerun that command to install bun, and now I should have bun installed, so I could use bun instead of node if I wanted to. Oh, actually, I'll probably have to open up a new bash shell, but now I do have bun. Okay, so you can really install whatever you want. You can run whichever commands you need to. We're going to be running a Node app, but it would be very simple to run a bun app, for example. So I'm going to clear this out. And the next thing I really want to do is get my code that I have for my application and put it onto this EC2 instance so we can actually run it on this instance instead of my laptop. So I have my source code over here. It's a basic Node application. I'm using Hono Node Server, which is kind of an alternative to Express, but it's very similar to Express. One big thing here, though, is that I'm using TypeScript instead of JavaScript. So I will have to build that into JavaScript, but I'll get to that in a moment. The first thing I need to do is get all of this source code onto my server, and then I can run the code. To do that, we can use SSH. There's a command called scp that will copy everything, and I should do this from my local instance. I'm going to stop running it on localhost, and what I would want to do is copy every single file to my remote EC2 instance. But instead of using scp, there is a slightly nicer command. I have it here, and I will share the link to all these snippets in the video description. So what I want to do is use a command called rsync. And this is handy for sending my code files to my EC2 instance because it will only send files that have changed. So if I'm in here and I send all my code for the first time, it's going to send everything. But if I just made a change to app.ts, for example, it would only send that if I ran the command again. So this is a much nicer command to run. We're going to exclude node modules. We don't want to send that to the server. We don't want to send the Git directory. We're going to leave out environment variable files. But this command will be good to send all the code. There's two things I need to change, and they are the SSH details that we used before to connect to the instance. So I'm going to specify what my SSH key is right here in this part. So it's in my SSH directory. This is the file I'm using. And then I want to connect to Ubuntu at this address. So let's see, I'll paste that in here, and I'm just using VS Code to edit this because it's a little bit nicer. So this command basically says we want to send everything in the current directory, that's the dot right here, this last line is the important part, everything in the current directory to my remote EC2 instance, and we're going to put it into a directory on that instance called app. That's just in the home directory. We're going to use the SSH key. That's the only thing that allows us to actually connect to the instance. And we're going to ignore certain directories and files. So before I paste this in here, I am just going to double check that I have nothing in the home directory. So on my Ubuntu instance, there's nothing that exists there right now. Then I'm inside my application. This is where my source code is, or my TypeScript code is, and I'm going to run that rsync command to send everything from my local machine up to that EC2 instance. So it sent all of those files, all the TypeScript files. And if I check on my remote instance now, I should see that I have an app directory because that's what I specified. And if I cd into there, I should see that I have all of my code files there. So now that those are on my remote instance, I want to see that I can actually run this Node application. So there's always going to be 2 steps to this, or 3, I guess, if you have to compile your TypeScript. The first thing you need to do is install dependencies. So I have Node installed, which means npm is my package manager. I just need to install those dependencies because they'll install differently on a Linux machine than they will locally on my Mac. So I'm going to install those here. Then once that's done running, if this were a JavaScript application, if it were an Express app, I might just run node app.js. But if it's a TypeScript project, so I have a TypeScript Hono project, this could be a Next.js app or any TypeScript app, there's going to be a build step, and I can just check the package.json for that. So the start script is usually for production, and then building happens before I can actually start. And this would be identical if I was using a Next.js app. So for me, the first step is going to be npm run build. And this might take a moment because it has to compile all the TypeScript into JavaScript, and I have a front-end React app, and it's also going to run the build command on that app too. But once that is finished running, I should have a bunch of JavaScript files that I can run with Node. And now that's finished, I should be able to see that I have in my dist directory a bunch of JavaScript files. So it's compiled everything into JavaScript, which is great. So now I should be able to run this with node source index.js. And it says module not found. All right, yeah. I meant node dist index.js. So this is just the entry point of the application. And actually you should probably have a start script that does this for you. So I'm going to run npm start, and this is running my server on port 3000. Great. Okay, so this is running now on the Ubuntu instance, which means that I should be able to access this over the internet. So I'll show you. If we go back into the EC2 dashboard over here, this is the instance I have. And if I go to networking, I can see that it has a public IPv4 address. So I can just copy this and put this into the browser, and I'm going to specify port 3000. So instead of localhost, I now have a remote IP address that anyone could visit. But if I hit enter, this isn't going to work. It's going to lag. It tells me it's not secure because I'm in Brave and it doesn't like that there isn't HTTPS. But even if I continue to the site, it still won't work. And that's because when I set up the instance, so let's go back here to security, we set up the security group, and this is the firewall for the instance. So it's not allowing traffic to come over port 3000. And you wouldn't want this in an application that you deploy. You wouldn't want people to access it over port 3000. You wanted them to access it over port 80 or more likely 443 over HTTPS. But just to test this out, just for the moment, I'm going to add a rule. I'm going to allow traffic to come over port 3000. And since this is just a basic test, I'm only going to allow it from my IP address. But I'm going to save that, and then immediately I should be able to see that my Node application is running. So that's my expense tracker. And if I wanted to share this with people, I could adjust the security group and allow anyone to visit this, and anyone could potentially now visit my web application. But if you notice on the homepage and the other pages, I will get an error. I'll just wait for that to come back up. There it is. An error has occurred. Something went wrong. It doesn't actually tell me what went wrong. If I go back onto the EC2 instance error logs, it's giving me these errors here. Error connection refused. It can't connect to localhost port 5432. And the reason it's giving me this error is because my Node application expects to connect to a Postgres database. If I go back to the source code and I check my environment variables, I have this environment variable to connect to a Postgres database running on my local machine, and the code is set up to connect to a Postgres database, but I don't have that database set up in the cloud, on the internet, on my EC2 instance. So the next thing I'm going to do is I'm going to stop this application from running, and I'm going to install Postgres on this EC2 instance so that my application can actually connect to a database. So for that, again, I'm going to go to my snippets here, and I have instructions for both MySQL and Postgres, and the steps are pretty much the same, and feel free to use whichever database you want. I just happen to be using Postgres here. So I am going to run this first command to install Postgres, and yeah, I have to confirm that I want to install that. Then once that's done installing, I'm going to start and enable Postgres, and that'll make sure that Postgres is always running even if I restart my EC2 instance. Once this is finished, paste in that to start up Postgres. And then I'm going to actually access the database here. And what I want to do is create a new database called My App. I'd call it whatever makes sense for the application. I'm going to create a new role called My App Role with this password. Choose better names, better passwords, but this will be fine for the demo. And then I'm going to grant all privileges on that app to that user. So let's paste this in here and create command not found. That's not good. Oh, right, because I'm not actually using Postgres, so I should start using Postgres, okay, and then I can paste in those SQL commands. Okay, great. So I now should have that database and that role set up. So that's going to mean that for my local instance, I think I actually use the same thing for my local host instance. My application just needs to know the role, the password, and the database that it should use. And I think I use the exact same thing here. And if I had the SQL to set up the database, the schema ready, I could just paste this in now and be done with it. But I actually have a migration system in my application. So I need to run my npm run migrate, which is going to run those SQLs for me. But before I can do that, I do need to give it that environment variable. So I'm going to paste in that environment variable, the database URL running on localhost, and then run npm run migrate. So it says the migrations were successful, and I could just test that out quickly. I'm going to try running PSQL with that URL to connect to that local database, and I should be able to see that my database has a single expenses table. That's all I have in this database, but the migration is successful. That database is set up on the instance. So I should now be able to run my web app and everything should work. So npm start, and it should run on localhost 3000. Actually, I need to give it the environment variable first and then run npm start. Always got to make sure that the environment variable is there. And now my application hopefully will work. So total spent now should be 0 if it can connect to the database, but something's failed. Let's see, what did I do wrong here? And now it's working. I guess I just pasted that in wrong before. Okay, so now it is working. Just tried it again and everything looks good now. So I should even be able to create a new expense, a thing for $10, submit that. There it's appearing from the database. If I go to the home page, there it is. So this is all working, and I have it set up that I can see the SQL statements as they're coming out too. So this is all working. It's connected to that Postgres database, and this is now a web application that's ready to start being used. One of the big issues is that it's running on port 3000 and it doesn't have a domain name. So now we need to fix those issues. But actually, before we fix those issues, there's one more thing we need to address here, and that's that we're currently running this application inside an active terminal. So if I was to close this window or just Control-C out of this, my entire web application would go down. So I need a way of running my Node application in the background so that it's always running no matter what I do. So to do that, I'm going to use systemd, which is a really common way of running things in the background. And the nice thing about systemd is it's going to work on any Linux machine for any application that you want to run. It's not specific to Node. So the first thing I'm going to do is actually create a file to store all the environment variables. And that's going to be in /etc/app.env. So I'm going to create that file there, and I'm going to put in the only environment variable that I have right now. But this contains some sensitive information, so I want to make sure that this is kind of hidden away from the rest of my application and the script that runs it. So I'm going to put that there, and then I'm going to save this file, and then I am going to change the permissions on this file so that it can only be read by Ubuntu when it's running this application. So I'll run those commands, that's good. And then we're going to create this system file. So this is the actual systemd part. We create a service file in this location, And this file is going to contain the instructions needed to run the Node app or any app that you're running. So I'm going to copy this code in, and then we can modify it as needed. This is the description. You would change that to be whatever you want to be for your application. You can leave this part alone. The user is going to be Ubuntu in this case. I happen to have put the application in the home directory. So that's /home/Ubuntu/app. So we're going to leave that alone because we want this to run in that directory. Then because this is a Node app using npm, we're going to run npm start. That's going to be the launch script. If anything goes wrong, if the app crashes or if we restart the server, we always want this application to restart. So we're going to tell it always restart if anything happens. We're going to set the Node environment to be production, point it to that environment variable file where we store the database URL. Then we have all the error logs and output logs going to syslog. And this is pretty standard. This means that the way you access any of the console logs or console errors is in a standard way on the system. And this is the identifier. I would actually change this to be something more meaningful. My expense tracker app. It will just make searching through the logs easier later on if you need to. But that's it for this file. So we can save this, and then we need to run the application as a service. So we just run these 3 lines of code. We have to reload because we made a new file, and then myapp.service is how we're going to reference this particular service. So I'm going to paste all 3 lines of code in there. And if everything went to plan, I should be able to access localhost 3000 and see my web app running. Yeah. Okay, so this app is now always running. So if I go back here and refresh, I will always be able to see my application no matter if I close that terminal window or do anything else. So that's really nice. And then if I did make an update to my application for whatever reason, let's say I just added a route here. Let's say app.get /test is gonna respond with, yeah, why not? Hello world. So I make a small update to my application. I would rerun the code to send that to the server. So that's the rsync command, and it sends that file up. And then on the back end, I would need to run sudo systemctl restart app.service. And then that would, and I didn't call it app.service. What did I call it? My app. Okay, so I'll just restart my app.service, and that should now have any updates applied. So if I'm here on my Ubuntu instance and I go to /test, I think I called it, then that doesn't exist. Why are you not working? I'm an idiot. I have to obviously npm run build because this is TypeScript code that needs to be compiled. And then I would need to restart the service. Okay, let's do that. My goodness. And now I should be able to sudo systemctl restart my app.service. And now I can't remember if it's API test or if it's /test. There we go. Okay, so now that works. And this is probably a good time to mention that all of these steps are obviously very manual. There's room for a lot of error there, as you've seen. And eventually you get to a point where you automate a lot of these tasks. But in order to get to that point where you can automate things and scale things well, you have to understand the foundational stuff and be able to set up EC2 instances from scratch. It might seem very manual at this point, but eventually you'll get to a point where you automate a lot of these things. The next thing I want to do is allow this to be accessed over HTTP, so I don't need that port 3000 there. And then we'll add a domain name and an SSL certificate. First, we are going to need a reverse proxy here because we don't want to allow our Node application that's running here to allow traffic on port 80 because that's a privileged port. And we also don't want the Node application to have to deal with things like SSL certificates. And we might not want our application to deal with CORS and other HTTP facing things like that. So instead, we can install a reverse proxy. And a really common one that I've used in the past has been Nginx, but something that I've started using recently that I really like is Caddy because it is really, really simple to get started with. So this is going to be our reverse proxy. It's going to be the thing that accepts HTTP requests and then forwards it onto the Node application. So I'm just going to click on install here and it should have an Ubuntu instruction. There we go. So I can copy and paste this in here and this will install the Caddy web server, which will allow connections on port 80. So while that's installing, I'm actually going to go back over to the security group section here and I'm going to edit those rules again to get rid of that custom 3000 rule because we're not going to need that anymore. We're going to allow HTTP and HTTPS over the public internet, and that's it. So I'll save those rules, and then that has installed. So I think I should be able to run systemctl start Caddy. I need sudo for that. And now if I curl localhost, so no port, just localhost port 80, it should give me, the Caddy homepage. And if I visit that in a browser, so if I get rid of that 3000, it will give me the standard Caddy homepage. Okay, cool. So I don't want that. What I want is to forward traffic to my application. So I'm going to come down here and I'm going to edit the Caddy file. So that's at /etc/caddy/caddy file. So let's do that. And here there's mainly comments, a few bits of configuration. We don't need most of these though. So I'm going to comment that out, and come down to this reverse proxy section, which I'm going to uncomment. And I need to go to the end here and change port 8080 to 3000. And all this is going to do is accept traffic on port 80 and forward that traffic to the application running on localhost 3000. So if I save this now and then restart Caddy, so restart, I should now see my Node application. There we go. Okay, so now I don't need that port 3000. This just works over port 80. Now, the next thing I want to do is actually have my own custom domain name there. And for this, you need to set up a domain on Route 53, and I have a quick 7-minute video on how to do that. So I'm going to assume you've already done that, or you can go ahead and do that right now. But once you have that, you can go back into the AWS console and head over to Route 53 and set up a custom domain for this EC2 instance. So I have a couple of hosted zones here. I'm going to use this smw.wtf domain, and I'm going to create a subdomain for this EC2 instance. So I want simple routing, or if you're in quick create, you can just do it like this. I'm going to switch to the wizard though. I like the simple routing. Click next, define a simple record, and this subdomain expenses. That's probably good actually. That's my application. We're going to do a route for this one, and the endpoint is going to be an IP address. And I'm going to go back over here and go to my instance that's running and make sure that I select the public IP address right here. So just that IP address. So I'm going to copy that, put that in here and define the simple record, and then I can create that record. So once that has been created, it can take a while for that to actually come into effect, but from experience, this usually always works for me. So if I come in here and I try to visit that domain, again, my browser is upset that it isn't HTTPS, but if I continue to cite, it does take me to my EC2 instance. So that's really cool. So now what I need is for this to be HTTPS, because right now this is using HTTP. And what I want is if someone goes to HTTP like this, expenses.smw.wtf, I want that to be forwarded to HTTPS. And if they go to HTTPS, then that should just work. It should have an SSL certificate already set up. And the way you do this with Caddy is really awesome. It's so simple. Go back into that Caddy file and modify it. And I'm going to go to this section here. And what I need to do is just put in my domain name. So I had expenses.smw.wtf. I'm actually just going to verify expenses.smw.wtf. Yep. Okay. So if I save this file now and restart Caddy, that's all I need to do. So now I just need to go and visit that domain name again. And the first time it might fail. No, it didn't. All right, that was instant this time. Okay, so now I'm visiting on HTTPS. It set up that SSL certificate. It's going to manage renewing that certificate if it expires. And if I go to HTTP, it's going to forward me over to HTTPS. So now that is a complete web app. I have HTTPS set up with a custom domain name. It forwards traffic to my Node application that's running on the instance that's using a Postgres database that's also installed on that instance. And this works for demoing applications or for very small scale applications. But if you get to a point where you need to manage lots of users or have lots of processing power on your web server, you will need to change how this works. You'll need to set up your applications for horizontal scaling. You'll need to set up your database for scaling and do database backups and manage a load balancer and a whole bunch of other things. But this is foundational. This is the stepping stone to get to those things. So you need to be able to practice this and be able to deploy web apps like this to then get to the point where you can manage these things at scale. I think that's it. I think that's the end. Okay, bye.